Alright, in this video we're going to talk about something called a function. The purpose of this video is to understand what a function is and how to identify it. So some things that we're going to be talking about, some vocabulary we're going to be using, is a function. Now a function is a relation in which each element of the domain is paired with exactly one member of the range. So that's stuff we talked about in chapter 1, things like relation, domain, and range, and we'll review that here in a second. Also, independent variable, that's the variable that contains the values of the domain. Typically, that's the x value. Dependent variable is a variable that contains the values of the range. Typically, that's the y values. Vertical line test, that's something we're going to use to determine if the graph of a relation is a function. A function rule is a rule or operations performed on the domain values to get the range values, and function notation is something that will be new to you, and that's a way to write a function in equation form. So all of those things that we're going to get to in this video. So first, a little bit of review so we understand what we're talking about. This is from chapter 1 on page 33. So if you want to pause the video and go back to page 33 and kind of refresh yourself on what a relation is, that would be great. But I can go over that really quickly right here. Now remember, a relation is basically a set of ordered pairs. And down here at the bottom of the screen, I have just some random ordered pairs in braces, and that's a relation. And a relation has two parts. It has all of the members of the domain, which we call the x values, which are also referred to as the independent variable, or they're called the input of a function. So all of these words in green pretty much mean the same thing. So 5, 2, -3, and 1 are all members of the domain. They are all the x values. They are all of the independent variables. They are all of the inputs in our relation. And then likewise, we have members of the range. These are all of the y values. These are all the dependent variables, or these are the outputs of a relation. So in my example, 4, 9, 6, and 10 are the members of the range. So hopefully that is a refresher on what a relation is. And that's all the farther we took that in chapter 1. Now we want to take it a step further and talk about special types of relations called functions. So what is a function? Well, it's a type of relation. It's a special type of relation that has every member of the domain has exactly one member of the range paired with it. Well, what does that mean? So, well, look at this example. This relation 2, 4, 3, 12, 6, 1, and 9, 10. Again, just some random ordered pairs. Now you'll notice that if I draw this out and I list all the members of the domain in this green bubble and pair them with the member of the range that they go with, you'll notice that every member of the domain is paired with only one member of the range. There are no duplicates here. So 2 is not paired with 2 separate members of the range. 3 is not paired with 2 separate members of the range. Every member of the domain has exactly one member of the range. And that is essentially what a function is. When every member of the domain has exactly one partner and one partner only in the range. And this is what that looks like if you map it out. If you look at this example, however, you'll see that this is not a function. And it's not a function because of the first 2 ordered pairs right here, 2, 1 and 2, 3. You'll notice that the member of the domain 2 is paired with 2 separate members of the range. So that disqualifies it from being a function. This is not a function. So if we look at these examples, we can ask, are these relations functions? Why or why not? Well, if you'd like to pause the video and see if you can figure out if these are functions, that'd be great. If not, I will explain to you if these are functions or not. And I notice that in this first one, I am missing my brace. There we go, that's better. So we have these 4 ordered pairs, 5, 1, 6, 3, 7, 5, and 8, 0. So I look at, when I'm looking to determine if this is a function or not, I look at the members of the domain, 5, 6, 7, and 8. I notice that no members repeat. It's 5, 6, 7, and 8, so there's no repeated x values, so I know that it's not going to be paired with a different member of the range. So every member of the domain has exactly one and a unique and different member of the range. So yes, that is a function. Here in 1b, we have our relation written in a table instead of listed as ordered pairs, but our ordered pairs are right here: 1, 7, 6, 6, 3, 2, 1, 8, 5, 2, and 2, 1. And scanning through the domain here, I see something here. 1 is repeated. 1 appears twice in the domain, and it is paired with 2 different members of the range, 7 and 8. So that means that this is not a function, because 1 member of the domain is paired with 2 separate members of the range. So that's one way to tell if something is a function. If you're looking at the relation, you're just looking at the ordered pairs, or you're looking at the table, look at the domain. See if there's a repeated member of the domain, and see if it is paired with 2 different members of the range. If that happens, then it is not a function. So think for a second, if we were to graph these points on a grid, what would that look like if these points were plotted? If 1, 7 and 1, 8 were plotted on a graph next to each other, what would that look like? Well, you can tell if something is a function or not by looking at its graph by using what we call the vertical line test. The vertical line test is a way to tell if a graph of a relation is a function or not. So these blue dots are this relation right here. I plotted all these points on the grid, and you'll notice that if you're looking at the ordered pairs, you can see these guys right here have a repeated domain value of 3, and it's paired with 2 different members of the range, 6 and 8. So this is not a function. So what does that look like on the graph? Well, you can see this vertical line right here. If I were to take a vertical line and kind of sweep it across the graph of my relation, you'll notice that right here, it goes through 2 points at the same time. These are the points 3, 6 and 3, 8. So you can tell that when 2 points are graphed vertically to each other or on top of each other, that it's easy to tell that this is not a function, because that's what's going to happen. You're going to see 2 dots that are plotted vertical to each other. So the vertical line test is a real easy visual way to tell if the graph of a relation is a function or not. So let's try it out. I've got a couple graphs here of relations, and we're trying to tell if these are functions or not. So if you'd like to pause the video again and see if you can tell if these are functions or not, go ahead and do that. But I'm going to explain whether these are or are not right now. So I've got a nice handy vertical line right here, and I'm going to grab it and drag it across my graph. Now you'll notice that it only touches 1 blue dot at a time. None of these blue dots are plotted vertical to each other. So it is safe to say that this is a function. Yes, these 5 ordered pairs do make a function. This one, if I grab this vertical line, here it crosses 1 red dot, 1 red dot, 1, 1, 1, and then here I run into a problem. These 2 red dots are plotted vertical to each other, so that disqualifies this relation as a function. So because of these 2 dots right here, this is not a function. So very easy to tell if a graph is a function or not, just by simply using the vertical line test. Here's a couple more graphs. Again, if you want to pause the video and check to see if you can determine whether these are functions or not, go ahead and do that. But let's take a look at the one on the left. This green line represents kind of a bunch of dots all put together. So if we take the blue vertical line and kind of drag it across, you'll notice that it never crosses the green line twice. It only crosses it at most once at any given spot. So this is a function. Easy to tell. And then the one on the right, this weird looking function here, or not function I should say, is not, because here, 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 and here, the vertical line crosses 2 spots, 2 points at once. So this is not a function. So again, whenever your vertical line crosses the graph in more than one place, that tells you that the same x value has 2 different y values, and it is not a function. So that's what a function is. That's how to tell what a function looks like with ordered pairs, or a table, or a graph. So next I want to talk about describing a function using a rule. So you can kind of use my visual here of my super awesome number cruncher. A function can be described as a relation that only has one output for every input. So again, we're talking about those inputs as x values or independent variables or members of the domain, and those outputs are the y values or the members of the range or the dependent variables. So when we put an x value in to our function, this is a function. For every x value we put into this function, it's going to perform some operations on it. It's going to do something to it, and then it's going to spit out an output. And hopefully every time I put one input in, I only get one output out. And that's what makes a function work. If this machine was spitting out different numbers for the same input, then we would say that the machine is broken and it is not functioning. So let me give you an example here. So here in this function, I put numbers in and I get numbers out. And I put them in a table here. So my input values were 2, 3, 4, and 5. So when I put a 2 in, I get a 4 out. When I put a 3 in, I get a 6 out. When I put a 4 in, I get an 8 out. And when I put a 5 in, I get a 10 out. So can you guess what rule or what operations this function is using to perform on every input? Well, if you said that it was taking the input and doubling it or multiplying it by 2, you would be correct. So we can write an equation to describe this function. Y is equal to 2 times x. Every time I put an input in, the function multiplies it by 2 and then spits out the value. And that is just simply a way to describe a function using the rule or an equation. Let's try another one. Here again, I used 1, 2, 3, and 4 as my domain or my input values or my x values. And here are my outputs. I put a 1 in, I get an 8 out. I put a 2 in, I get a 9 out. I put a 3 in, I get a 10 out. I put a 4 in, I get an 11 out. Can you guess what the rule for this function is? Y equals x plus 7. So really it's just an equation that relates the inputs or the domain values to the outputs or the range values. So every time I put an x into this function, my function adds 7 to it and spits out the output y. Let's try this one. This one's a little more challenging. So again, for my input values, I picked 1, 2, 3, and 4. So if I put a 1 in, I get a 4 out. If I put a 2 in, I get a 9 out. If I put a 3 in, I get a 14 out. If I put a 4 in, I get a 19 out. The rule for this function is y equals 5 times x minus 1. 5 times 1 is 5, minus 1 is 4, 5 times 2 is 10, minus 1 is 9, and so on and so forth. So again, these equations just describe what's happening to x, what operations are being performed on the inputs to get the y values or our outputs. So this is yet another way to describe a function. And you'll know that every time I put a number in for x, I better get the same y value out. So if I put a 2 into this function, I better always get a 9 out. Otherwise, this machine's broken and it's not working correctly. So every x value will always get one unique y value out. So this is a function. One thing to add to this is something called function notation. This is just another way to write the rule that the function is using. So we have been writing our functions in the form of an equation, y equals. Function notation is something that's a little bit different, and it's written like it is on the right-hand side here, where this is read f of x equals 2x plus 3 instead of y. So we replace the y with an f of x, which means this is a function of x. This does not mean f times x, that's what it kind of looks like, but in function notation it's not. The f is not a variable, and it has no mathematical purpose whatsoever. It's an abbreviation for function. It's a function of x. That means x is the input, and f of x, the function, is 2 times x plus 3. So don't get too confused by that. You can think of it as just y, or our output. So how to use function notation? So if we were writing our function rule like this, f of x equals 4x minus 7, again, you can kind of think of this as y equals 4x minus 7, but we're just, again, describing it using function notation. It allows us to use kind of some shorthand, like you see here where it says find f of 5, and that's how you read that, f of 5, and that means find the value of the function when x is 5, or I'm going to use 5 as my input into this function. What is the output going to be? So whenever you see this notation, it's just asking you to put in 5 for x. So in red here, I work this out. F of 5 is 4 times 5 minus 7. I just put 5 in as my x value, or as my input, and that's 20 minus 7. So f of 5 equals 13. In other words, the value of the function is 13, or it's going to spit out a 13 when 5 is the input. And then another example, find f of negative 6. That means what is the output going to be when x, or the input, is negative 6. So f of negative 6 equals 4 times negative 6 minus 7. 4 times negative 6 is negative 24. Negative 24 minus 7 is negative 31. So f of negative 6 is negative 31. So really, it's just a matter of notation. There's really nothing mathematically different happening here. We're just writing in it's kind of a nice shorthand for evaluating functions. So let's try a couple of examples here. Here's my function, f of x equals 14 plus 3x, and we're going to find our outputs. What is the value of this function when x is 4? So what is f of 4? So to find f of 4, I'm just simply going to put 4 in to the function. And that is 14 plus 12. So f of 4 is 26. Easy peasy. Next one, f of negative 7. F of negative 7 is the value of the function when x is negative 7. So that gives me 14 plus negative 21. And 14 plus negative 21 is negative 7. So f of negative 7 is actually negative 7. So there you go. So evaluating functions with function notation, pretty straightforward. It's actually kind of easy once you get the hang of it. So in conclusion and summary, 1, a function is a relation that has only one output, or a y value or a range value, for every input, the x values or the domain value. 2, a function will never have 2 points graphed vertical to each other. So we can use the vertical line test to determine if a graph is a function. And finally, function notation is just a way to write the rule or the equation that relates the input values and the output values. Hopefully that was helpful to you.